Okay, Science 10s, this is a little recap of properties of ionic, molecular acids and bases. We have seen some excellent videos already on how to tell these different substances apart. And so I just wanted to show you guys again. So we've got ionic compound, sodium chloride, molecular compound glucose, an acid, and a base. Okay, we've got acetic acid and sodium hydroxide. So the next thing here is I want to show you, and we've already seen this, sodium chloride is blue litmus, stays blue. Red litmus stays red. But here's something, is that we know that litmus is great for acids and bases, right? We know that it is going to tell you if a pH is less than 7, we know it's an acid. If the red is going to stay red and the blue turns red, we know it's an acid. But here's the deal. How do we, that's just a ballpark figure, right? How can we find a little bit more specific pH? How are we going to be able to tell what the pH is? So this we know is a neutral compound, right? We've got sodium chloride, blue stays blue, red stays red. So we know it's neutral. Same for glucose. This time, though, this is a molecular compound. Blue stays blue, red stays red. But the acid is going to be a different story. And we can see here that the blue has turned pink or red, and the red stays red. And then if I compare that to a base, I'm looking at the base over here. Blue stays blue, and the red goes blue. But how acidic or how basic are these things? Neutral is easy, right? No change in litmus. And if I want to be a little bit more specific than just my ballpark figure, I can use a piece of this, which is called our universal indicator, our universal pH paper. And our universal pH paper actually has a little scale. And you can see that according to the scale, the pH, is about 7. So we knew that sodium chloride was neutral. We know that glucose is neutral. But now I compare it to acetic acid. And look at this. It comes in at a pH of around 3 maybe. Okay, let's compare that to sodium hydroxide over here. Kind of a dark blue, maybe 11 or 12. So this is just a way we know that our litmus can say if a pH is less than 7 or greater than 7, but it won't tell us a very specific, a more precise measure. And so we can use universal pH paper for that. We could also use what is called a pH meter, but those are more expensive and they will give you a much more precise reading. Like it could tell you, is the pH 7.000 or is that sodium hydroxide 11.2212, right? It is much more specific, but they're more expensive and not as convenient to use. So we also looked at conductivity, and when we do our conductivity testing, we just take our little conductivity meter and we press the little button and then look, oh, there the light's going on. That tells us this solution is conductive. There is ions in solution. This is an electrolyte. All right, winner, winner, chicken dinner. Okay, so electrolyte solutions conduct electricity, so they include ionic compounds. So there was our example, sodium hydroxide. Do you think that just plain tap water is going to go ahead and conduct? Light's not coming on. Molecular compounds don't conduct. Why? No metals, no ions. No metals, no ions. Okay, what about this acid that we have? Well, remember that acids either have an H at the beginning of the formula or like acetic acid, a COOH ending. And the deal is they have hydrogen ions, and those hydrogen ions are what are going to conduct. So look at that. The light goes on. This is an electrolyte. This solution conducts electricity because of the ions that are present. So just FYI, I'm washing off the conductivity meter and drying it in between each. I don't want to contaminate my next solution. Okay, so now let's take a look at glucose. Remember, we've seen these already. Glucose, we predict, is not going to conduct. This is a molecular compound. There are no ions. This is nonmetal, not conducting. Okay, that's pretty obvious. What about sodium chloride? What about sodium chloride? It's not a base, it's not an acid, but it is an ionic compound. Sodium chloride is made of ions. There's a metal cation, the sodium ion, and there is a chloride anion. Look at that guy go. All right, this is a conductive solution. This is an electrolyte. Okay, so now what are some other solutions that you might have around your house, around your home? Well, I bet that you've got a cleaning solution that is around your home that is called Windex, which is just basically a solution of ammonia. And so when we look at ammonia, we can see blue stays blue, red turns blue. So we know the pH is above 7. Well, how much above 7? I don't know. Well, not until I do, sorry, leaning over to grab it, not until I do this. So there we go, kind of maybe around a pH of 8 or so. Using my universal indicator, I ballparked. I knew it was above 7. This helps me get a more specific reading. Now I'm going to show you a little secret here. Windex looks like NH2 nonmetals. Shouldn't conduct, should it? Let's take a look and see. Oh, what? How come this is conducting? I thought molecular compounds didn't conduct. I thought molecular compounds had no ions. I thought molecular compounds were nonmetal only. Well, guys, ammonia is an exception to that rule. Ammonia does conduct electricity. It is an exception. Okay, so it actually, as we look at it, is a base, and yes, it conducts. Now let's take a look at something else you might have just sitting around your home, and that is isopropyl alcohol. That is rubbing alcohol. So you probably have this at home, and you put it on a cut, and you use it to clear off your cut. And you can see, it doesn't even look like I dipped these in water at all, right? Here's the blue. Stays blue. Red stays red. What about this universal pH? Is that going to help me any? Nope, not much of a help. That's just showing me the pH is 7. That is neutral. Let's see about conductivity. Okay, I just need to clean my conductivity meter. I don't want to get my conductivity meter contaminating one solution to the next, so I'm going to clean it off. Let's see what happens in this molecular compound. And do we get the light glowing? Oh, well, you know what? Molecular compounds, we should have expected that, right? Molecular compounds do not conduct. Light does not glow. All right, and finally, you might have a bottle of Gatorade, and they claim it's an electrolyte. They claim that Gatorade is going to be an electrolyte, so we would think that it would conduct electricity. Pink, red stays red. My blue, you can see, went red. What happens with? So it should be acidic, but it doesn't look like it's very acidic. Maybe it's a pH of 6. Not too acidic. Let's see what happens now with my conductivity. Are they right when they say it's an electrolyte? Are they right? Does it conduct electricity? Let's take a look. Oh, wait. I saw it flash there for a second. I thought it did conduct. Maybe not. Maybe their claim that it is an electrolyte is not true. Okay, I thought it was a sugary drink. Oh, there we go. It is an electrolyte. There are ions in this solution. This is an electrolyte solution as they claim. Okay, guys, that is it for kind of part 2 of our lab. Acids, bases, molecular, ionic compounds. Talk later.